Good afternoon, fellow classmates. I hope you guys are doing well. My name is Zawad, and today I'm going to talk about our application, which is called Your Dream Car. It is created by myself and my partners Kanika and Suraj. So let's get started. So, first of all, we're going to talk about the goal of our project. So as the name suggests, this application will help a customer to choose their own features that they would like in a car. So if you're a car person who wants to customize your car, and in many cases, we can see that we don't get the desired features in a car that we're looking for in the market. So what this application does is that it helps you to order a car from our application that will have the features you want, and we do that by letting you choose the performance that best suits you, the appearance that you would like on the car, and after taking those inputs, we can show you the price of the car and also an estimated monthly cost of running the car. Hello guys, so this is a short demo about our application. So as you can see, we have four screens here: performance, appearance, payment method, and receipt. So first of all, I would like to show you what happens if the user doesn't choose anything. That is that he leaves all of these as it is. So if you just click on this button, so here you can see there's a description of the car, which is our default car, which is a sports car with 2 seats and has the fuel type diesel. The default car has a price of 12,886, and these are the following monthly cost for that. So now, what if the user starts choosing something? For example, I'm choosing engine size of 2000, method of fuel as petrol, and then I'm choosing off-road tires, and this is your regular all-season tires, which comes in default. I'm choosing manual for transmission, and a horsepower of 300. And appearance will be this color, yellow. And then this car type would be hatchback. Let's choose a seat of 6, additional lights for fog, and then we can choose the electronic stability. And remember that all car comes with the airbags. And we choose the payment methods. As you can see in the receipt, all of this has changed. The engine size, the fuel type, horsepower, seats, and everything has all been updated. And let's choose a different payment method now. So let's choose 50%, and let's see what's the difference. As you can see, when you choose 50% down payment in the total cost of the car area, it shows the 50% down payment here, and then this is your monthly cost for the next 12 months. One more thing to note here is that there's an estimated gas cost for every month, but however, if you choose uh, electric car and update it with the button, and you can see that the estimated gas cost is 0 because we don't use any gas for the electric cars. So in our performance section, the users can choose their required engine size, the type of fuel that should be used in the car, the car type, and the type of tires they want in the car, the transmission, and as well as the required horsepower needed to run the car smoothly. So as you can see, this is our performance tile, and we have used a slider for the engine size, a choice box for the method of fuel, some check boxes for the type of tires they would like. For the transmission type, we have used 3 toggle buttons, and the horsepower is just a text box. So let's have a look at them in detail. As you can see, the engine slider is set as fit to scale, which means they can only choose from the numbers which are labeled in text, for example, 1000, 1250, or 2000 perhaps, or maybe 3500, etc. For the fuel type, we have used choice box, which lets them choose among diesel, petrol, electric, or a hybrid car. Then we have the type of tires they want in the package, which includes multiple selection of tires if they want, which can be included because some people would want off-road tires and also the regular tires and maybe the winter tires as well. And they can change their tires according to the season. In the transmission type, people can choose whether they want their car to be automatic geared, manual geared, or if they like it both ways, so they can choose dual transmission. For the horsepower, however, the users can only choose between a range of 100 and 500. If they choose anything which is out of the range, or if they give any invalid inputs such as letters or any other characters, then the horsepower will be automatically calculated according to their engine size. So let's have a look at how our code looks like for the horsepower. As you can see here that this method calculates the horsepower cost by taking two parameters x and y. So first of all, we're going to assign x as chosen horsepower and y as chosen engine size. So if the horsepower is in the valid range, we're going to calculate the cost by multiplying the chosen horsepower with the horsepower multiplier, which is in fact the average horsepower cost of a car. And if it's not in the valid range, we calculate the horsepower automatically by multiplying the engine size with the constant. So as you can tell, horsepower and engine size are directly proportional. Secondly, what if they choose a digit which is not in the valid range? So in that case, what we are going to do is we'll just show them an error label that you cannot use that value as a horsepower, and the horsepower will be automatically calculated according to their engine size. Moving on to our next part of the application, which is the appearance section. So for the appearance, we take 5 factors, which includes the color, type of car, number of seats, additional lights, and safety features. So for the appearance, we take 5 factors, which includes the color, type of car, number of seats, additional lights, and safety features. So this is how our appearance screen looks like. If we just take a look before going in depth. For the colors, as you can see, there is a color picker where people can choose from a range of color. They can also customize their own color from this custom color option. For the car type, we let them choose among 7 different types, which is SUV, sedan, hatchback, truck, sports car, a van, or a limousine. And then we have a choice box for the additional lights, which includes several categories. So what if they want to customize their headlights or their tail lights, or in fact, or they want some additional fog lights so they could see well in the dark. So something like that can also be included. For the number of seats, they can only choose an even number of seats to a maximum of 8. The slider is set so that it's always gonna fit to scale. It might sound a bit weird that you can customize your car however you like, so that you can also choose the limousine with 2 seats or a sedan with 6 seats. I know it sounds awkward, but as the name suggests, it's your dream car and you can do whatever you want. So let's have a look at how we calculated the color cost. Firstly, we divided them into 2 sections, so the sedan, SUV, van, or hatchback will have the same price added to their total. The other types, however, will have another cost. In this algorithm, if the user chooses among these four types, it is known that their car type cost will be lower than or equal to 3,500, and we assign the color cost to cost 1. Or else, if it's not 3,500, it means they have chosen either limousine, truck, or a sports car. We are going to assign the color cost as cost 2.
Hi, my name is Suraj and I'll be speaking about the payment method tab. The payment method tab consists of three options for the user to choose from. The first option being a full payment with no down payment. The second option being 50% down payment with a 12 months financing, and the last option being 25% down payment, 24 months of financing. Continuing from the previous slide, we shall take a closer look at the different payment options the user can choose from. The first payment option is a full payment option in which the user does not have to pay any down payment or any kind of interest. But the second payment option is a 50% down payment with 12 months of financing, which includes a 10% interest rate per annum. The last option being a 25% down payment for 24 months of financing, which includes a 15% interest rate per annum. Speaking about the next tab being the receipt tab, this tab contains default messages prompting the user to choose a payment method from the previous tab, which is the payment method tab. These messages are displayed when the user does not choose any kind of payment method in the payment method tab, and also these text messages are replaced when the user chooses a payment method from the payment method tab. Now let's take a look at the background calculations that take place when the user clicks on the full payment button in the payment method tab. When the user clicks on the full payment, the full payment cost method is called. Here we calculate an estimate of the car by adding up the insurance cost and the total cost of gas, and then display it in the receipt tab. Now let's take a look at the background calculations that take place when the user clicks on the 50% down payment plus 12 months of financing option. When the user clicks on this option, the half down cost method is called. In this method, we calculate the total cost of the car by adding up the 50% down payment and the amount which the user has to pay monthly, including the 10% interest rate. Now let's take a look at the last option, which is the 25% down payment plus 24 months of financing. When the user chooses this option, the quarter down cost method is called. In this method, we calculate the total cost of the car by adding up 25% of the down payment and the monthly payment which the user has to pay every month, including the 15% interest rate per annum. Next, let's take a look at the receipt tab, which gives us all the essential information related to the car. The receipt tab displays all the information of the car from the inputs given by the user in all the three tabs, which are the performance tab, appearance tab, and the payment method tab. We shall now take a look at the code used for building your dream car. Let's take a look at the get car type cost method. This method takes in string as an argument and returns double. We have a string array which contains the different types of cars and an int array which contains the cost for each type of car. When the user chooses the type of car of their choice, this method is called, and then the price is calculated based on the user's choice. The get fuel cost method is similar to the get car type cost method. The get fuel cost method takes in string as an argument and returns double. Here we have two arrays. The first array is a string type which contains the different types of fuels, and the next one being an int array which contains the cost of each kind of fuel. When the user chooses their choice of fuel for their dream car, this method is called, and the price of the fuel is calculated based on the user's choice. The getLights cost method also takes in string as an argument and returns double.
The complex code also includes the code as shown for the electric car type, where we set the gas price equal to 0 if the customer chooses the car type as electric. Otherwise, it is set to the normal gas price in the else statement, that is 160 CAD. The application is still working when no input is given by the customer, where we set it to some default values to be used when customer doesn't want to make any modifications. So the default values could be seen here as in the receipt shown. Now moving on to the next part of our presentation, which is the UML diagram for our application. So this is how our UML diagram looks like, where it apparently has 5 classes in total. There are 3 main classes and the other 2 are the child classes. This is a detailed version of a UML diagram. There is a card data controller at the top which has 3 types of payment methods: full, half down and quarter down. The monthly cost on its right is connected to it through the monthly cost method called in the controller. Then next are the two parent classes, appearance cost and performance cost, which has child classes, appearance labor cost and performance labor cost, where we made the use of inheritance in our application. The classes represent all the variables used at the top and the methods are represented below it. Here is a one by one representation of all the classes used in making up our application. So beginning with the monthly cost here, it's using two instance variables, car cost taking a double and the type of a fuel taking a string. The methods are insurance cost, that's calculating the cost according to the total cost as modifications are made by the customers. The insurance cost is divided here into three categories. First one being the cost under the range of 15,000. The second is between 15,000 and 25,000, and the last one being above 25,000 cap. This performance cost class is one of our parent classes which takes 5 instance variables, all double as could be seen in the diagram. So it has engine size cost, fuel cost, horsepower and transmission type cost, basically which is used to define the performance of the car. The This performance labor cost class is the child class of performance cost. It calculates the labor cost for making the car using the performance cost and wage percentage, which is already defined in the code. The next parent class used is the appearance cost, which takes all the inputs mentioned for creating the appearance of the car, and as it uses the methods to calculate the specific cost and then the total appearance cost by adding all of them together. The appearance labor cost is the child class of appearance cost, doing the same work as the performance labor cost, except that it calculates the labor cost using the appearance cost and the percentage of wages. It uses one instance variable, appearance labor cost, taking the double input and calculating the labor cost. So we faced in total 6 challenges while working on this project. Firstly, we had difficulty in representing the same colors chosen on the appearance tab as on the receipt tab, which was made to show all the inputs selected. So the color selected was showing some random characters and not the one which was actually chosen by the customer. Secondly, we face a lot of errors while showing inputs chosen on the receipt tab as the description of the car. Also, we were not able to connect parent and the child classes properly in the application since it always used to mess up the code and didn't run. We also had difficulty while figuring out how to display the labels and not creating more errors. And when we were able to display a label, we noticed that it was not working for signs and alphabets and therefore only works for wrong digits. So this was some sort of difficulty as we used the condition for that and it didn't seem to work for the invalid data. To fix the color thing on receipt tab, we just added another color picker through the scene builder and connected it to the initial one used through color2.setValue, which takes color.getValue. For the description part, we used the scene builder where we added the labels and wrote the inputs taken for the description of the car. The lecture recordings for the inheritance helped us in figuring out the connection between the parent and the child classes. To display the labels, we refer to the Great Calculator Coding Challenge and did the same process, which worked for us with zero errors. And at last, we modified the condition to show the accurate value of the horsepower given, which was valid as well. So this ends our presentation. Hope you like our application and use it to make your ride better.